Welcome back to The Explainer. Today, we're shining a massive spotlight on the invisible digital heroes that literally silently orchestrate our modern lives. Whether you're submitting an assignment at school, streaming a video, or honestly just checking your email, there is a massive, completely hidden infrastructure working tirelessly behind the scenes to make it all happen. Today, we are decoding that invisible infrastructure. We're talking about network servers.
So here's our digital blueprint for today. Number 1, meet the digital heroes. 2, translators and assigners. 3, the 4 network workhorses. 4, choosing the right server. And 5, real-world network scenarios. Let's just dive right in.
Section 1. Meet the digital heroes. Let's set the baseline for our networks.
What actually happens when you connect to school Wi-Fi and open a website? We do this literally every single day, right? You walk into a building, flip open your laptop or tap your phone, and boom, you're connected. But if you stop and think about the exact steps, it reveals the hidden chaos of an unmanaged network. Without a specific set of rules and dedicated machines directing traffic, assigning identities, and fetching data, your device would basically just be shouting into a digital void. So, who actually answers the call?
Well, at its core, a server is exactly what it sounds like. It's a system that provides, or serves, resources to other devices, which we call clients. The absolutely crucial takeaway here is that servers are dedicated responders. They don't need human prompting. They just run continuously, manage multiple users seamlessly, and are always listening for a client's request.
Just imagine a central hub radiating outward. Right in the center, your specialized server acts as the anchor, and radiating all around it are the clients. Your laptops, phones, printers, all of that. The server's sole purpose is bringing absolute order to this chaotic web of constant requests, making sure our digital heroes are always providing highly available service.
Section 2. Translators and assigners. Let's look at how we actually navigate the network. Okay, before you can do anything, you need 2 massive problems solved: identity and navigation. When you open your laptop, the DHCP server instantly solves the identity problem. It assigns you an IP address so you aren't just invisible. Then comes navigation. You type a web address, and the DNS server steps in to translate a human-friendly name like school.edu into a numerical IP address. Without these 2 navigators working together, honestly, you're going nowhere.
Section 3. The 4 network workhorses. Let's check out the functional servers.
Once you're on, notice how specialized these roles get. You've got your mail servers, which dedicate their entire existence to managing, sending, and storing the massive volume of our daily communications. Meanwhile, proxy servers act as these clever intermediaries. They stand right on the front line, receiving client requests first. That allows them to filter out malicious sites, monitor traffic, and basically shield your internal devices from the outside world.
Rounding out our core workhorses, we've got file and web servers. Think of the file server as the ultimate digital filing cabinet. It's managing shared documents, massive backups, and keeping strict user permissions in check. The web server, on the other hand, is your public face. It's the engine that's delivering web pages, images, and applications directly to browsers worldwide.
Section 4. Choosing the right server. How to actually evaluate your design choices. So, the absolute first question any network architect must ask is, what specific service must the network provide? You have to match the tool to the job. A shared folder system demands a file server. Automatic IP assignment? Well, that demands a DHCP server. If you mismatch the function, like, say, trying to use a web server to hand out IP addresses, you end up with a wildly unmanageable, fragile network. Function is always your foundation.
Now that foundational function dictates our next core factors, scalability and reliability. And while they might sound kind of similar, they evaluate totally different realities. Scalability is all about growth, like can performance hold up when hundreds of students log in at the exact same time? Reliability, though, that's about survival. What happens when hardware fails? If a core authentication service goes down, your whole organization just halts. So redundancy here isn't a luxury, it's an absolute requirement.
But all that design is completely meaningless without security, because let's face it, a highly scalable server lacking basic defenses is really just a faster disaster. And security profiles look drastically different for every single role. File servers demand incredibly strict permissions. Mail servers need aggressive spam filtering to block phishing attempts. Proxies are actually deployed as security tools themselves to enforce use policies. And web servers? Since they sit completely exposed on the public internet, they require massive defense against external attacks.
Section 5. Real-world network scenarios.
Time to apply those architect skills. When we pull all these variables together into a master evaluation, notice how the priorities shift depending on the specific server type. For a web server, scalability is entirely focused on handling sudden traffic spikes and keeping response times fast. But look at a file server. Its scalability challenge is totally different. It's all about managing massive storage growth and concurrent file access. Similarly, if a DHCP server lacks reliability and fails, literally no new devices can even join the network. Every single server type has a totally unique, delicate balance of function, scale, reliability, and security.
So, based on the specific functions, scalability demands, reliability requirements, and security risks we've just evaluated, I want to leave you with a bit of a provocative challenge. Imagine you're tasked with setting up a network for a brand new, small school. They need to host a website, get laptops connected, share teacher files, and keep students off unsafe sites. How would you design their server needs? Which of these digital heroes would you prioritize, and why? I want you to really think through those key factors we discussed today. Thank you so much for joining me on this explainer. Keep asking those great questions, and I'll see you next time.